Rakshit. So people, Rakshit Gondwal is from Punjab College of Engineering, and he is going to speak on autoscaling Kubernetes workload balance on metrics. In this talk, he will explain the use of metrics to autoscale Kubernetes workload with the help of horizontal pod autoscaler.
So, hey everyone. First of all, I'd like to thank you all for joining me here at my talk, and also a big thanks to the organizers for giving me the opportunity to speak here at KCD Mumbai. And this is my first time speaking at a conference. So yeah, I am a little bit nervous, but a lot more excited. So today I'm going to speak about autoscaling Kubernetes workloads based on metrics. Now, not just metrics, but I'll tell you all how you can scale your workloads based on unified observability data. So this is going to be a beginner to intermediate level talk. I'll cover first the beginner level topics, and then I'll move on to the intermediate things. So a little bit about myself. My name is Rakshit Gondwal. I'm a Google Summer of Code mentee for CNCF organization, working under the Keptn project. I am also a team member of We Make Devs community, and I love contributing to open source and communities. I've contributed to a lot of CNCF projects, and you can find me on Twitter at Rakshit Gondwal. You can, if you want, you can have a look at my GitHub at Rakshit Gondwal, or you can just scan the QR code for all the links. Cool. So the main problems that we are going to tackle today are the first, the need to manually scale. In this, I'll tell you about how you can auto-scale your workloads and what are the challenges you face while scaling your workloads manually. Then we'll talk about observability tools sprawl. This would make a much more sense once we talk about HPA. So I'll leave this for later. Cool. So let me start by a scenario. So suppose I am working in a company and I have a website. Take this container as a website. So now I have to go on a vacation this week. Now my manager told me that this week we are having a festival, so there would be a lot of traffic on our website. So a lot of users might be visiting our website this week. So can you please take care of that? So my manager told me that, and what I do is I just scale my deployments of website that is deployed on Kubernetes so that it can handle the traffic on its own. Now my manager told me that we have released a new feature this week, and there might be a lot more traffic than expected. So can you also take care of that? So what I do is I manually scale my website to a lot more deployments. Now at the weekend, when I'm at the vacation enjoying, there can be two scenarios. Three scenarios actually. One, everything goes well, the traffic is very well settled, but what happens if there is a lot extra traffic than we expected? So there might be the website crash, or things might not work properly, or everything would happen but the website working properly, or there are less number of users visiting the website, but yeah, that would lead to overcost of your company. Now this is what I just spoke about. Manually scaling leads to too few resources when there is a lot of traffic. So it can lead to latency, outages, then bad user experience, or if there are too many resources, it can lead to all those resources are waste, and a lot of bill is coming for your company because you have deployed a lot of deployments on your cluster. Now this is where autoscaling comes into the picture. Now what autoscaling do for you is, when you don't need to manually scale your workloads, you can just define a metric or a scenario, like suppose there are 30 users coming in. So I want the autoscaler to autoscale itself on 5 deployments or 10 deployments. Or if 5 users are coming in, I want you to scale down to 1 deployment or 5 deployment. So in Kubernetes, there are several autoscalers available. The first one is cluster autoscaler, vertical pod autoscaler, and horizontal pod autoscaler. Now, HPA is the one that I'm going to be more focused on because I think it is the most powerful one. So I'll just quickly go through all types of cluster autoscalers. Cluster autoscaler, it basically scales the number of nodes. Like if in a node your pods are not working, so it will simply scale the it will simply create a new node with that number of pods. This might take a lot of time because what usually happens is your cluster is deployed on a cloud, so it is dependent how much time the cloud vendor would take to create a new node actually. So yeah, and a lot of resources would be unused because some pods might not be working in the cluster, in the node. So that would still exist, and it's very less efficient actually. Now comes the VPA, or the vertical pod autoscaler. Now let me explain like this. Suppose this is a pod. Now I want when 30 users are coming in, the VPA would scale it to this. So like the size increases of the pod, as you can see in the example, before scaling, there were 2 CPUs and 2 GB of memory. And after after the autoscaling was done, there are 4 CPUs and 4 GB of memory. And obviously, you can set limits in the VPA that I only want you to scale till 20 GB of RAM and that all. Now comes the HPA. Now, HPA, according to me, is the most powerful autoscaler out there, and it is the most efficient. Now, what it does is, like this is a pod. I'll tell it to, when 30 users are coming in, I'll tell it to, scale horizontally. Like it will create a lot more replicas of your deployment. 1, 2, 3. So it scales horizontally, and the key part or the main point why HPA is useful is it can scale on the basis of custom metrics. Now, your custom metrics can come from various observability tools such as Prometheus, Dynatrace, Datadog, etc. And you can simply define your autoscaling policies that when this metric hits this point, you need to scale up, and when you need to scale down. And yeah, a lot of flexibility for metric selection. This totally depends on the observability tool that you are using. Like some metrics are provided by a specific observability tool, like Datadog provides a different metrics, and Prometheus provides different metrics. Yeah, this is just a table I've created. You can take a screen photo of it if you want for future reference. Then this was just, I thought this would be relevant, but here's a deployment. And if we apply VPA, it scales vertically. And if we apply HPA, there are a lot more, replicas of that house. Just a basic example. Now, I think I've given you a little bit of context what autoscaling is and what HPA does. Now comes the main part of observability tools sprawl. So, as I told you, HPA scrapes metrics from observability providers like Prometheus, Dynatrace, Datadog. Now, when you are working in an organization, there can be a lot of tools which you are using to scrape metrics from. Like you might be using Prometheus, Datadog, New Relic, Splunk, then KEDA is also an autoscaling tool. It scales horizontally too. So things can go often, difficult to manage all these integrations, these plugins. So we need a standard to, simplify all this stuff so that it can get easier for us to maintain these integrations and these plugins. So the standard I want to introduce you all to is the Keptn Metrics Operator. Now, what Keptn Metrics Operator does for you is, it will scrape the metrics for you from the provider, and then it will, just expose these metrics via the Kubernetes API or Prometheus, and then tools like HPA, KDA can scrape them from the API or Prometheus. Now, yeah, what you need to do is just define a metrics provider. It is a CRD. Keptn Metrics Provider acts as a CRD you need to define. As you can see, the first one is a Keptn Metric Provider. We have defined Prometheus and the target server that Prometheus is deployed on. A simple namespace. Namespace should be the one where your application is running. And then a CRD for your metric that you want to extract from the provider. The namespace should also be the one where our application is running. Then the name of the provider above, same. Then a query that you want, the main metric that you want to extract from the observability tool. A simple fetch interval seconds for, after how many times you want to query the tool for the latest metric. Now, I think there's a lot, I just spoke a lot of theory, so we'll move to the demo now. Now, what I'll show you in a demo, there will be a Kubernetes cluster. I'll have an application deployed on the cluster. Then I'll have the Keptn Metrics Operator deployed on the cluster too. Then we'll apply the provider, which will be connected to the Prometheus, and a Keptn Metrics CRD that will be getting spec from operator will be getting spec from the Keptn Metrics CRD and will be writing the results into its status. If you know about operators, then there are two fields in a CRD. One is spec and a status. Spec is the thing that we define, and status is what we get from the results get written in the status of the CRD. Then we'll simply query the operator using a HPA, and we'll see the application autoscaled. Cool. So yeah, let me first show you what we have in the deployment. So here's the basic application that I have. It's deployed in Potato kubectl namespace, then all the basic stuff, the resources, limits, and I have a service deployed to. We'll deploy this. Yeah, so I have it already deployed so that there are no difficulties for the demo. It's unchanged because I had already deployed it earlier. Now, get on and pod. You can see the pod is running, the deployment is running, and the service is running. This is default configuration that we are providing with the basic deployment.yaml. Now we can see what our metrics provider look like. As I just showed you in the previous slide, type Prometheus target server. I have deployed Prometheus into my monitoring namespace to monitor my application. So you'll need to have a observability tool connected to your application. Now I'll also show you the metric. This is the Keptn metric, the same as I showed you in the slide. A query, fetch interval seconds, and the name of the provider that we have already deployed as a CRD. So I'll apply these both. Sorry. Yeah, it was previously deployed to, it's just unchanged. And Keptn metric, my bad. Yeah, it is unchanged too. So now we can get the value of our metric. Now, in usual scenarios, what you might do is go to the provider and see what the value of your metric is coming out. But you can simply see the metric using one command using the Keptn Metrics Operator, kubectl get Keptn metric and see the metric that I'm getting from Prometheus is 2.84. Now you can scale your workloads based on this metric, 2.84. You can say, if the value is above 1, I need you to scale up. If the value is below 1, I need you to scale down. Now, I have already a HPA file ready. You can see the minimum number of replicas is 1 and the maximum replicas is 3. That means I want you to scale up till 3 and the minimum I want you to scale down is 1. Then we have just defined the metric that we just deployed and the value at the last 1. It means that the metrics operator is configured in such a way that HPA will scale up if the value goes above from 1 and it will scale down if the value goes below 1. So apply F. My bad. Yep, the HPA was applied. So as we saw earlier, there were only one pod. Now we can get all and you can see the HPA has been applied, minimum number of pods 1, max number of pods 3. It is still in work. I mean, the HPA is still auto scaling this. Yeah, you can see the pod has been started creating. There were 3. I gave the maximum replicas to be 3 and the value should be above 1. The target was 1 and the value coming out is 2.84. Now it has automatically scaled the deployment, the pods to 3 and it should be ready now, I think. Yeah, the pod is running now. So that was how you can, a basic demo of how you can utilize the Keptn Metrics Operator. Now I just used a single observability tool, that was Prometheus. But you can define any number of metric providers like Prometheus, Dynatrace, Datadog, as many as you want, and just you won't have to keep track of all these plugins and integrations. You just need one file for all your Keptn metric or all your metrics and observability provider. Now that we have seen the demo, let's move on to how this metrics operator is working. The metrics operator is basically divided into 2 parts, the controller and the adapter. There's just a very basic thing that these two do. Controller is used to fetch metrics and adapter is used to expose the metrics, so that the exposed metrics can be used by tools like HPA or KDA, and the controller fetches metrics from your observability tool. Yep, the same thing in the definition. Now, there can be endless possibilities of this Keptn Metrics Operator. You don't just need to, use this for scaling your workloads, but you can use these metrics for Argo CD or your GitOps deployment. Can I get a raise of hands? How many of you are using GitOps here, Argo CD here? Okay, so you all might be using Argo rollouts too. If you are, then Argo rollouts, make the canary deployments based on data, if it is right or wrong. So you can use the Keptn Metrics Operator for there too. And yeah, that was all for my talk. Any questions? Yeah. Mm-hmm. Mm-hmm. I just showed you that we can configure the fetch interval seconds. So there you can, at the last, we have fetch interval seconds. You can define after, after these are the fetch interval seconds. In this, the operator is constantly querying the provider in between 10 seconds. So you can use this as 1 second, 2 second, 3 second as per your use case. Okay. Uh, Thank you. I saw one hand there. Yeah. Can we get the mic over there? I am not actually able to listen.
Hi. So if I just have two questions. If to get
Sorry,
a
I
better
can't hear you.
understanding, am I audible?
Yeah.
Yeah. So if I understand correct, this is scaling the pods horizontally, right?
Okay.
So in HPA by default, we can also scale based on metrics server, right? So is it similar to like kind of replacing metrics server, the Keptn metrics?
Not really. The metrics, it's an operator that comes in between your observability provider and the HPA. So the provider is the operator is a separate thing. It will just fetch metrics and expose it via the Kubernetes API or Prometheus. So as you can see, most of the tools, they can fetch metrics for using the Prometheus format. Like the metrics which are exposed by Prometheus are a different format or so yeah, that's why we have mainly focused on Kubernetes API and the Prometheus.
Okay, so basically what this additionally provides is scraping the metrics from various observability tools compared to metrics server. So that's something additional being provided by Keptn.
Yeah, so that you don't have to, take care of all those plugins, because you'll have to, every different provider has a different plugin for different tool. So you don't really need to take care of that. Just deploy the operator and things will work for you.
Okay. And another one, so this, as you said, only horizontally scales the pod, right? It doesn't add nodes, right?
It adds more pods.
So, I mean, we have seen certain issues in adding more pods, because if we are running our workloads on EKS cluster, right? The cluster or the EC2 instances limits the number of pods. So how do we, cater to that? I mean, if I give like my maximum pods to be 100, say, but certain EC2 types doesn't help in, running more than certain number of pods. There is a limit to it. So ultimately we'll have to add more nodes.
Like I think that's the issue with the cloud provider that you will be using.
Okay.
So you will have to, choose that. You will have to take care of that your own, I think, because you will have to see how many, or you have to see your billing plan, how many the number of pods your cloud provider is actually giving you, and then use the...
I mean, we can increase the node to increase the pod, but then ultimately that will cost, right? We cannot keep on running the same higher configuration.
Yeah.
But right now, I mean, Keptn doesn't help in scaling the nodes, right? The worker nodes.
No, it will only help you increasing the pods.
Thanks.
Thank you. Any more questions? Cool. Then, yeah, that was all. Thank you for being such a great audience. And you can meet me around here. I would be happy to have a chat with you if you want to. I'm actually working on this operator in my GSOC project too. I'm implementing new features for this operator. So yeah, if you'd like to know more, just you can have a chat with me, and I'll love to have a chat with you. Thank you.
Yes, thank you, Rakshit, for this wonderful workshop. And congratulations to you, as this was your first talk.